Okay, the first thing we're going to start off with are polynomials. And the first thing we're going to look at are linear, which are degree 1. And they're in the form y equals mx plus b. And they're called degree 1 because the exponent on x is a 1. Now, what do we know about these? We learned about these in grade 10. We know that the b is our y-intercept. And it's also the number without a variable, which means it will remain constant no matter what variable I fill it in. So we can call it the y-intercept. It's also called the constant. Now, what is the constant? The constant is when you have an equation with no brackets, It is the term without a variable. And from grade 10, we know that the m is the slope. We are also going to call it the leading coefficient, because the coefficient is the number in front, and the leading coefficient is the number in front of the largest variable, because it leads the equation. So we're going to write that, leading coefficient. The number in front of the largest exponent. So if we look at the equation y equals negative 3x plus 6, we know the constant is the number without a variable, so the constant is equal to 6. The leading coefficient equals negative 3, because it's the number in front of the largest exponent. We know this is a degree 1, because the exponent on the largest exponent is a 1, which makes this linear. Okay? Now, what we did tell you is the constant is the y-intercept. So I know I have a y-intercept at the coordinate 0, 6. My leading coefficient, which is my slope in this case, just because it's linear, the sign of the leading coefficient tells me how it ends on the right. So because the sign of my leading coefficient is negative, I know it ends the graph ends down on the right. Okay, so if I go to draw this, I know I have a y-intercept at 6. 1, 2, 3, 4, 5, 6. And now I know I have a slope. My slope is -3 over 1. So that means it goes down 3, right 1. From the y-intercept. So we'll start at the y-intercept. So I'm going to go down 3. 1, 2, 3. Down 3. 1, 2, 3, right 1. Down 3. 1, 2, 3, right 1. And then I connect to those. And I have a linear equation. Wow, pretend that went through the green dot up there. That was pretty sad. I have a linear equation with a y-intercept at 0, 6. And I end down on the right. So my leading coefficient tells me how I end down, how I end on the right, which is down, and my constant at the back is my y-intercept. Now linear functions end down on the right. That means that they'll end up on the left because linear are always in opposite directions. To the next page. Linear end behavior. Oops, touch the screen. End in opposite directions. So for the last one, you'd say the end behavior would have been up on left, down on right. So if I gave you y equals 3x minus 2, I would know that my y-intercept is at 0 and -2, which is my constant. And I know that my leading coefficient equals +3. Now that positive tells me how it ends on the right. So it ends up on the right. Man, this messy writing is driving me crazy. Sorry. It ends up on the right. Okay? So if I were to sketch this, I have a -2 as my y-intercept. And then my slope is 3 over 1. So I rise before I run. Just like if you were in bed, you have to rise before you run, or you're just running in bed. So I rise up 3, and I run 1 right. So I rise up 3, 1, 2, 3, run 1 right. And then I'm going to try and connect them better than I did last time. Oof. This is bad. Pretend they're going through the dots. So now let's prove if I'm right. You can check it. I should have a y-intercept at -3, or at -2, sorry, which I do. And I should be ending up on right, which I am, which means I end down on left, which I did. So you basing it on being linear, I know it has to be in opposite directions. It's up on right, it's down on left. Okay? My domain and range for linear functions are the easiest because my domain, because the arrows are going in opposite directions, my domain is squiggly bracket, which means the set of x values such that x is an element of the real numbers. And my range is y such that y is an element of the real numbers. It doesn't change. Okay? So I can give you an equation and ask you for that stuff, or I could give you a graph and ask you for that stuff. Let's see if I give you a graph of a linear. So if I give you a graph of a linear, this is my graph. And it looks like this. Doesn't have to be accurate other than where it's going through the y. So I'm going to make it go like this, up, this. I'm going to make it pass through here. Okay? So I know I have a y-intercept at 2, 0, 2, and I also know that I'm up on the right. From that, you can give me two pieces of information. You can tell me if it's up on the right. That tells me I have a up on the right because it depends on how it ends on the right. If it ends up on the right, that indirectly tells me I have a positive leading coefficient. That number that leads the largest variable. If it was down on the right, I'd have a negative leading coefficient. That's it. And my y-intercept tells me what my constant is. Doesn't change. My constant, in this case, equals 2. Cool, hey? And the domain and range will never change. So if you look at the right, it's up on the right, I have a positive leading coefficient. If it had been down on the right instead, I would have a negative leading coefficient. And wherever my y-intercept is my constant. My domain and my range are always x-er, y-er. And the left-hand arrow on a linear will always be in the opposite direction. So because it's up on the right, it's going to be down on the left. That's how I know how to draw it. How do you know it's linear? This is linear, which is degree 1. How do I know that? It's a straight line with no bumps. That's it. Straight line. No bumps. Boom. That is linear. I'll do a quadratic and I'll do a cubic, and that's your lessons for the week. But I'll put them separate.